Good afternoon. How's everybody doing? Welcome to the Thursday afternoon lecture. So good to see you. Good to see you, Etta and Leanne and whoever else happens to be here. If you want to say hello, just go ahead and type in the chat bar. It's good to see you. It's good to see you. Thanks to everybody that came out on the Wednesday webinar last night. Holy cow, we had a great crowd. I was totally impressed with how many of you showed up and how many of you participated. Or I guess that was Tuesday night, not Wednesday. It was Tuesday night, no, Wednesday night. I can't keep my days straight. And Kinsey, I don't know if Kinsey is here today, but Kinsey shared a beautiful video of a child that had a chromosome disorder. And after watching this young girl talk for about 2 minutes, there's no way you could ever say that her life was a waste. I've never seen such a happy, healthy young lady. There's a lot of things she can't do that we can. She'll probably never be able to take care of herself, but her life was a light and a joy. And if anybody's interested, I can share you that video. It was absolutely uplifting and really made me smile. When I was working at the Miracle League, one of the things that I noticed is that even though a lot of these kids had really terrible handicaps and problems, they still got out there on the ball field and smiled and had the greatest time. And I thought, you know, who be it for me or anyone else to judge what their life is worth? Yeah, I'll go ahead and I'll send that around after class because it'll be good. So anybody have any questions, problems, things we need to sort out before we get started on lecture? Got 8 people so far. I'm hoping a couple people show up, so I may delay this lecture for just a moment. Remember, this Tuesday and Thursday lecture is just for this week and this week only. We will be going back to the Monday, Wednesday lectures for the rest of the semester starting next week. I'll send a reminder out about it so nobody forgets, and I'll probably even mention it again at the end of class today. Crystal is here. Whoop, whoop. Ah, cool. Crystal, Ear Candy, Chicago. I forget. It's Crystal Bishop, right? Not Eigenreither. I always forget which one is Ear Candy. The man trying to hold me down. That sounds like Crystal Bishop. Yep, I thought so. Okay, don't let the man hold you down. Fight the power, girl. Fight the power. And hold on to your kitty cats. Okay, let's see. It is 1:01, and we've got 8 viewers. Kind of a light class today, but not bad. I'm glad to see. Oh, cool. Okay, it shows up when you're on your phone. I'm glad to see everybody's here. Let's go ahead and start, and hopefully today's lecture won't last as long as Tuesday's lecture did. So today we're going to talk about reproductive challenging and genetics research. So we're going to be talking about the 6 types of prenatal diagnostic tests that can be done to help evaluate the health of your developing child, as well as the risks associated with each. We're going to talk a little bit about reproductive technologies for people who have difficulty conceiving, and we'll talk about the changing pattern of adoption. We'll talk about adoption patterns in the U.S. and outcomes for adopted children. I'll look at that. Looks like we've got both crystals. I got Crystal Squared in here today. It's going to be a full crystal day. I'm glad to see that. Good to see you again, Crystal E. Okay, we'll talk about behavioral geneticists, how they use twin studies to assess heritability and the heritability environmental connections that make it difficult. And we'll talk a little bit, I don't know if I'm going to talk about epigenetics. I don't know if I have that slide in here. But we're going to go ahead and talk about some of these issues today in class. So let's go ahead and get started. Now, one of the things that you want to do when that modern medicine does. Remember, we talked about how we've increased the lifespan and life quality of human beings over the last 100 years. It all starts out in the womb with prenatal diagnostic tests that allow doctors to assess and evaluate the quality of your child's development even before they are born. And so we're going to talk a little bit about these. After I say hello to Violetta Cheptanari, who is stopping in today. It's good to see you. Oh, wow, we've got 14 people in now. Wow, full class. I'll stop real quick and say we've got Douglas Dong. Good to see you. Good to see everybody who's in here today. So the one thing that you're almost all going to do, those of you who have had children or been with someone who's had children. I've been with someone who's had children and not actually had them myself. I don't want to misrepresent myself, but one of the things that we all seem to get is the ultrasound sonography, which is where they put that greasy gel on the mom's belly, and then they slide that little machine over the mom's belly to use sound waves to get sort of an echo image of the fetus. And this is where we can often see the sex of the child. And I think it happens I think it's the 12th week, I think that they do that. Any mothers out there want to correct my thinking? I think that's in the 12th to 14th week. Is it? And that allows you to see how well the baby's developing. So at 12 weeks, the baby should have certain sort of bodily features. So you can see if the arms and the legs and in the head and all that sort of beginning to develop in a healthy and normal way. You can also show the sex of the baby. Now, the neat thing about the ultrasound sonography and why they do it for every mother is because it's completely safe. It does not carry any risk of diagnostic procedure. It is very safe. The only problem is it doesn't really tell you about genetic or chromosome disorders that may be occurring. Now, another, I guess we would say, safe and non-threatening type of approach is the maternal blood screening, which I'm going to slip all the way down to the bottom. It's not typically used, especially for normal pregnancies, because it gives false positives a lot of times. Now, when you're diagnosing things using chemical tests, blood tests, and this comes from a branch of science called decision theory. These tests that we give that measure indicators of diseases, they are not 100% accurate. Sometimes they have false positives. Sometimes they miss a disorder when it's there. And the better the test, the fewer false positives and misses that it has. But the maternal blood screening, the problem with the maternal blood screening is it gives lots of false positives. And although in that's number one, it really upsets and disrupts parents and causes a great deal of stress, which is not helpful for a baby. And it suggests more invasive methods. And invasive methods are dangerous because they do carry a slight risk of miscarriage. So even though ultrasound and maternal blood screening aren't dangerous to the baby, they may not be as diagnostic as they need to be. Okay, 5th month. They do it in the 5th month as well. Yeah, actually, I think insurance pays for 2 ultrasounds. Thank you, Amal. You're right, I forgot the one that comes later. But they usually take the Guppy gel and put the ultrasound wand on you at least twice during the pregnancy. Yes, it definitely causes stress. Okay, so the 2 other tests that we're going to talk about. You know what? And on the notes, I said 6 types of prenatal diagnostic tests, and I'm only going to talk about 4. Sorry about that. That's a typo on my first screen. I do apologize for that. The second one that your book talks about is chorionic villus sampling, CVS. And basically what they do is they go in there and take a little snip of the placenta. And they can do that anywhere from 10 to 12 weeks. And that's where they can really, it's more diagnostic because they can go in there and see if there are any genetic chromosomal abnormalities that really aren't going to be shown on the ultrasound sonography and that may be shown falsely on the maternal blood screening. The only problem is the CVS is it is invasive. invasive, and it does carry a slight risk of miscarriage. I think the CVS and the amniocentesis, if you look in your book, they're going to have sort of like a 1% chance of miscarriage. And 1% doesn't sound high, but think about how many thousands and millions of babies are born every year. And so really, that's quite a high risk. So they typically don't do that unless the ultrasound sonography or the mom's age or the maternal blood screening shows something that might be problematic. Yes, they do both have a slight risk. Now, the amniocentesis. The amniocentesis, they actually take a needle and stick that into the mother's belly, into the amniotic fluid sac that surrounds the baby, and sample that amniotic fluid. Unlike the chorionic villus sampling, it happens a little bit later in prenatal development, the 15th to the 18th week. And again, it provides a better test of genetic and chromosomal abnormalities. Again, there is a slight risk of miscarriage, so it's only used if the ultrasound sonography, the mother's health, or the mother's age makes this an option for the doctor. As I'm asking anybody, have any of you ever had experience with CVS or amniocentesis? I'm assuming all you mothers got the ultrasound because that's kind of a rite of passage. It's a fun thing for the mom and dad to find out the sex of the baby if they want to know. But does anybody have, because you're actually sticking a needle into that amniotic sac, you might tear the amniotic sac and cause the fluid to leak out. You might damage the baby. You might hit the umbilical cord. You're poking a big old needle into the belly. And the same thing with the the chorionic villus sampling. You're sticking a needle into the baby with a little cute cutter there. And whenever you're sticking something into that belly, you run the risk of damaging the amniotic sac, the placenta, or the baby. And so that's why they carry that slight risk. Now, of course, you say, well, they're being done by trained professionals. They shouldn't be a mistake. But you know what? How many of you are good at your job and have ever made a mistake? Or I know babies don't like to stay still. They sometimes move around a little bit. They're floating around in that sac. So even though they are pretty safe, things can happen. I hope that helps, Davina. Now, I had a good friend who was infertile, and her husband were unable to conceive a baby. And of course, they went through the period where they were trying to find out if it was the husband or the female, and they found out that it was her difficulty. She was having difficulty. She was having difficulty producing eggs and having eggs come down into the fallopian tube. So what they did was they did in vitro fertilization. And what they do with in vitro fertilization is they take the eggs and the sperm out of the mom, combine them in a laboratory, and create zygotes or fertilized eggs, which are then put back into the mom's uterus. Actually, I take that back. My brother as well, he and his wife, he got married, and they got married when he was 40. Well, they tried to have a baby when he was like 45 and she was 40, and she was just at that age where it was difficult for her to conceive, and so they had to use the IVF. And so they took the egg and the sperm out of each of them and combined them outside in the lab and put them into her uterus. Now, I think what I remember my brother telling me is they put 4 fertilized eggs into her belly, and the idea is that not all of these fertilized eggs, not all of these zygotes are going to be viable. So from what I understand, and please feel free to step in and correct me if I'm wrong, I think a lot of times they will put in more than 1 or 2. And the IVF success rate does depend on the mother's age and other factors. So if you look down below here, what you're going to see is the likelihood of the mother actually keeping the little zygote in, and then the actual baby being born. And what you'll see is that the success of IVF certainly goes down as the mother gets older. Have any of you ever heard of the case of Octomon, Nadia Suleimani? Does anybody remember that case from 7 years ago? This lady had 8 eggs implanted into her, 8 fertilized eggs implanted into her uterus and gave birth to 8 babies. Anybody ever remember that? Holy cow, and the world was super duper pissed because she had already had IVF a couple of times, and I think she's got either 14 or 16 kids right now, and people were really angry because they thought that she was going to need help taking care of those babies. I think she found a benefactor to take care of those, but people were not really happy with her choosing to have 8 babies at one time. You know, she did have that very exotic Angelina Jolie look. You know, I do remember that, Etta, when I saw her, she definitely favored Angelina Jolie. Yes. Okay, now, so that's sort of just some basics about prenatal testing and IVF. Behavioral genetics. One of the things that are very interesting to developmental psychologists is the idea of nature or nurture. How much of a trait or a human quality is created by your genetic nature, and how much of your genetic quality is created by the environment that you grow up in. The branch of science that is interested in that is called behavioral geneticists. And what they do is they use the genetic similarity of different kinds of family members and compare that with people who are unrelated by blood, and they look to see if the concordance rate of traits decreases as you become more genetically unsimilar. So the concordance rate is the degree to which 2 people picked out of a pot are similar for a given trait. So if you think about it, you and I, any of you in this class, I see there are 18 of you watching this lecture. Let's say I had a disorder. Let's say I was schizophrenic, and we then picked one of you out of the class and asked the question, are you schizophrenic? If one of you also came up schizophrenic, we would say that we were concordant for that trait of schizophrenia. Okay? Now, it turns out that the concordance rate for schizophrenia is somewhere between strangers is somewhere about 1%. So what we know is that in the general population, 1% of us is going to develop schizophrenia. And if you remember from chapter 14 in Psych 150, I talked to you about the incidence rate. The normal incidence rate of schizophrenia is 1%. And when we talk about incidence rates of any disorder, we talk about the likelihood of 2 random people picked at random will have that trait. And that's how we figure out the base rate of how likely disorders are. And so I think they say that 10% of us will suffer some sort of depressive episode in our life. And so if I had depression and I picked 2 of you from at random of this 18 class, there's a chance that at least 2 of you in this class have depression as well, even though we are not genetically related. And so that allows us to assess, if you will, the base rate for schizophrenia. And so what you do is you compare the base rate for a disorder or a trait with the concordance rate for people who are more genetically similar. Now, in twin studies, what we do is we compare the behavioral similarity of identical and fraternal twins, of parents, of cousins. And as you move down that list, you get more genetically dissimilar. And so if we see the concordance rates increase as we get more genetically similar, then we begin to guess that that trait has some sort of genetic component. On the other hand, what we can do is we can take family members that are not related by blood, stepbrothers, stepsisters, adopted children, and we can compare the concordance rates for those people who are related by family situation but not genetics. And if we see that people who live together but aren't genetically related have a higher degree of concordance, then we begin to guess and estimate that environment somehow has an impact on a trait. And so twin studies and adoption studies fall into this larger umbrella of behavioral genetics, where we attempt to assess the degree to which human qualities are determined by nature or nurture. Does that make sense? Okay. You know, I have my slides out of order today, so I'm going to skip over two and talk about genetic similarity among siblings. Specifically, when we're talking about twin studies, if you think about it, siblings share about 25% genetic similarity. Now, you may think of fraternal twins as being more genetically similar, but really, fraternal twins are two eggs fertilized by two different sperm cells. So they really are just like a regular brother and sister that share a womb service for 9 months. I know. Bad joke. Bad jokes. Hi, Haley. How are you doing? I see we have Haley in here. It's good to see you. Okay. So siblings share about 25% genetic similarity. And so do fraternal dizygotic twins. Right? Now, identical monozygotic twins is a single fertilized egg cell that is fertilized by a single sperm, and then after fertilization, this zygote splits into two babies. Identical twins are 100% genetically similar. All right? So, what we do is we compare we compare the concordance rates for these different levels of genetic similarity. And if you look at the chart below me, not below me, but sort of at an angle down here, what you'll see is the concordance rate for a trait we'll call, or actually for three personality traits. One we'll call happiness, one we'll call neuroticism, and one we'll call self-control. And what you see are concordance rates for different levels of genetic similarity. The blue bar represents concordance rates for identical twins. The red bar represents the concordance rate for dizygotic twins. And then the gray bar represents the base rate that you will see in people who share the same home but are not genetically related. And what you'll see is the concordance drops greatly from identical twins to fraternal twins, and drops to almost nothing and drops much lower for twins that are raised in the same house. And so what we would say is that positive emotionality is probably more genetic than it is nurture. Same thing with neuroticism. It's more genetic than it is environmental. And what you'll see down here, constraint is more genetic than it is environmental. However, constraint, your parents teaching you self-control, is to some degree determined by the environment. And we're going to talk about the ways in which you can help your children develop self-control, because really that's going to be more important for your success and happiness than your actual intellect. Okay, any questions so far? Haley's one of my students from last semester, for those of you who are wondering, and she's dropping in to say hello and spread her cheers. And Haley, I'd like to raise my cup of coffee to you and give you a salute. Thank you for showing up today. It's good to see you as always. Okay, so no more questions? Fantastic. Let's roll on to, let's go back up. Let's see. Okay. Actually, now, here's the deal. People who also share genetic similarity, a lot of times, Oh, excuse me. Actually, let me go back one quick. As we talk throughout this semester, I'm going to suggest to you that there are three broad human qualities that do seem to show a genetic component. Personality appears to show a genetic component. So the fact that one of my sons is a butthead, I can't blame it on his raising. I have to blame it on his father's genetic material. My wife often says that Junior is just like his dad. And every time I say, God, he's such a butthead, I have to go look in the mirror and face the fact that I am also a butthead, right? Personality. Now, both of my boys are smart as whips, too. And I take a positive thumbs up for that because I say, hey, they got my genetic material. Now, my wife will tell you they got her genetic material, too. And frankly, she's every bit as clever as me. So hopefully my kids are smart because they got it from their parents. And you know what? Mental illness does show a genetic component. In fact, if you have an identical twin that suffers from schizophrenia, your likelihood of having schizophrenia as well is almost 50%. So there's an incredibly high concordance rate for schizophrenia for identical twins. Yeah, I'm something else. You see only the good side. You got to see me being angry because I have the worst freaking temper. I try to control it, but I just can't. Okay, now, here's the thing. People who show the same environment also seem to show that share the same genetic component a lot of times seem to show the same and have the same environment as well. So identical twins do grow up in the same house a lot of times. Fraternal twins and siblings, regular siblings, they grow up in the same house all the time. You know what? My son, even though he is genetically similar to me, he grew up around my temper. So the question is, did he get my temper from my genes or did he get it from my behavior, right? And so your book's going to talk about ways in which heredity and environment sort of correlate so that you might have a genetic predisposition to start with, and then that genetic predisposition can be further developed by an environmental situation that you're in. And I'm going to mention three different people that you will actually find on your homework and on your test who represent the different kinds of heredity-environment correlations. The first is what we would call the passive heredity-environment correlation. Now, I'm a Van Halen fan. Woohoo! I grew up in the 80s, and David Lee Roth and Eddie Van Halen were my guitar heroes. I had their posters on the wall. I wanted to be like them. I loved them, right? And gosh, I think 1990, Eddie Van Halen had a son that he named Wolfgang. Can you think of anybody else who's named Wolfgang? Who but a musician, a guitar virtuoso, would name their child Wolfgang, right? Plus, you'd have to be a rock star. I would not send my kid to school with the name of Wolfie unless he was a rock star son. Now, Wolfgang probably got genetic material from his father, Eddie, who got it from his father, Jan, who was also a musician in, goodness me, crap, I forget exactly where they're from, somewhere over in Eastern Europe. You did know a Wolfgang. No doubt. Huh. That's just not a name you're going to see every day here in the United States. Was he from Europe? That's interesting. Very interesting. Now, here's the deal. Eddie Van Halen's son grew up in a world of music. His dad was playing music all the time. There were guitars. Actually, Eddie Van Halen could play. He was trained first as a classical pianist, and he even won the state championship 4 years in a row as a preteen in California, a very big state. So his dad learned how to play piano. His dad actually, when he and his brother Alex decided to become musicians, the first instrument that they bought, Eddie bought the drums and Alex bought the guitar. And Eddie learned how to play the drums, but he found out he was a better guitarist than his brother Alex, and Alex liked to play the drums more, so they actually switched instruments. So Eddie learned how to play the guitar. He then learned how to play the drums. He then learned how to play the bass guitar. And he also could sing. And he sang in his first band called Mammoth back in the early 70s. And so Eddie could do all of those things. So think about it. He has this son, and this son grows up in a world that's just scattered with music. All he's doing is he's hearing music every day. He's seeing musical instruments. So this is sort of a passive environment. So even though he has some of the genetic trait, the environment created around him created such an environment that it nurtured whatever genetic abilities he may had. So even though we see this genetic concordance rate, and Wolfgang is now a rock star in his own right, you can say, yeah, it was probably the genes, but he also had the passive environment that would sort of nurture that particular trait. Now, sometimes a child may be born with a genetic tendency that their parents notice, and when the parents notices that skill, the parent then creates an environment to nurture that skill. So in a sense, the kid's genetic tendency evokes a certain environment. Now, in that story, I'm going to relate a story about a fellow named the Rain Man. Oh my goodness, the name just popped out of me. Kim Peek. Kim Peek, they called him the Rain Man, or Human Google. He was born quite brain damaged as a child. He had what they called agenesis of the corpus callosum. He didn't have two hemispheres. His brain was just all mushed together into one big brain lump. And he looked quite retarded as an infant baby. And the doctors wanted really his mom and dad to put him in an institution and forget about him. That's what a doctor told him. But they didn't. They instead gave Kim all the love they possibly could. But they noticed something crazy. At 2 years of age, Kim Peek crawled over to the bookcase, pulled out an encyclopedia, and began reading the encyclopedia at 2 years of age. His parents were stunned by his reading ability, because really kids start reading those C-Spot Run books at about the age of 5 or 6. This kid was reading freaking encyclopedias at 2.5 years of age. His parents noticed that he had this prodigious talent. So you know what they did? They started dragging him to the library to read, because they noticed he had this talent, and that evoked an environment around him. Now, it turns out, if you believe the story, he read the left page with his left eye, he read the right page with his right eye, and he could read a page in 9 to 10 seconds. And so they would take him to the library, and this kid devoured 10 to 15 books every day. He just read all the freaking books in the Pasadena library. And his genetic ability at the beginning caused his parents to create an environment, evoked an environment around him that then nurtured that ability. So yeah, I know, I do want skill like that, to read the left. And you know what? There's no question you can ask this guy that he can't answer. He is the human Google. Now, the crazy thing is, there's a difference between memory and thinking. And it turns out that Kim Peek is not a good thinker. He can't solve problems. So if you ask him how to do a mathematical problem or how to get to the library, he doesn't have problem-solving skills. So he's very, he's what they call an idiot savant. He's really limited in a lot of areas, but in terms of remembering facts, this dude is as good as Google. So he's book smart, right. He's knowledge smart, but not thinking smart. But the point I was trying to make is his parents noticed this ability and then created an environment which evoked this kind of ability. So is it genes? Is it nurture? Well, in both of these cases, it's genes and nurture. Now, probably, and then there's the third heredity environment correlation that your book talks about, which we would call the active or niche picking heredity environment correlation. And this is where maybe the parents don't necessarily notice the prodigious ability, but the child has an ability or something they really like to do. And so then they go out and the child actively finds things that sort of nurture that ability. So maybe mom and dad aren't paying a bit of attention, but the child notices it and goes out and finds things to sort of develop that unique ability. Now, I don't know if you folks have ever seen the movie Free Solo. It's actually available on Disney Films, on the Disney app if you want. And it talks about a fellow named Alex Honnold. Alex Honnold is a master climber. This guy, in fact, is so awesome that he is the first person to free solo El Capitan. Free soloing means climbing without ropes or any support. Just dangerous, dangerous, dangerous. He climbed a 3,000-foot cliff with no ropes, and it took him about 4 hours. Now, how did he get to this particular, and in fact, he lives in a van. The guy doesn't even have a house. He doesn't work a job. He does just enough work to put gas in his van, and he lives and eats out of his van, and he has these little finger holds where he practices lifting his fingers, lifting himself on his fingers. This guy, in the movie, he says he climbed everything as a little kid. Trees, rocks, small cliffs, small hills. And because he had this prodigious ability, he went out and found his own environments to nurture this ability. Now, this is different from the passive where the stuff surrounds you. This is different from evocative, where the parents see you have an ability and create an environment for you. Instead, he actively went out and picked an environment to nurture this amazing skill that he had. And so, he bought that house after he free soloed. He bought that after he free soloed because he got rich. Because climbing El Capitan is absolutely stupid crazy. If any of you go Google Yosemite National Park, El Capitan, and look at that cliff, the first thing you're going to say, just like me, is, oh, hell no. I wouldn't climb that with a rope. This dude climbed it with nothing, just scaled right up. And I think it took him like 4 hours to climb 3,000 feet. Absolutely insano, right? Now, I do want to go back a couple of slides. I had my slides all out of order, and I do apologize about that. But adoption is another way for building a family. And so adoption is a social and legal process that establishes a parent-child relationship between persons unrelated at birth. Now, adoptive parents and children in the U.S. have become more diverse. In the early half of the 20th century, most adoptive parents were white and non-Latinos. And you know what they were adopting? Infant, white, non-Latino children. And so, the deal was if you were an older kid, 3, 4, 5, 6, certainly in the teenage years, nobody wanted to accept you as an adopted child. Most parents were looking for babies. And they were mostly white, wealthy, heterosexual couples. Now, it's become more diverse in the later half of the 20th century, but I will tell you, my wife and I have a couple friend that are married, a homosexual couple friend. Both of these folks are really smart men who make a ton of money. And here in the state of North Carolina, they have had a devil of a time trying to adopt a baby simply because of their sexual orientation. And in fact, they've been ripped off a couple of times for giving money to organizations that just take their money and don't even follow up with them because they know there are no repercussions for stealing their money. And if you ever met this couple, you would, right, it's so rude. And if you've ever met this couple, they're absolutely intelligent, charming, hardworking, with good jobs, a nice place. These are the kind of people that should. And it's because people seem to have this irrational fear that somehow living in with homosexual parents will somehow change your child's sexual identity. And the question I would have, well, then what does that say about the child that grows up in a heterosexual family and realizes that they are homosexual, right? That's sort of like the opposite of it, and that doesn't necessarily stop any child. But that is the way, unfortunately, it is. But hopefully things are changing and we'll be getting even more diverse as we move into the 21st century. Really, it should depend upon your emotional control, your financial resources, and not on your sexual orientation, your color, or your nationality. Now, outcomes for adopted children are way better for those that are raised in long-term foster care, of course. You've got this one family that can attend to your needs, give you the financial resources that maybe you won't find in foster care. So, of course, the outcomes are going to be much better. And it turns out that children who are adopted at a very early age seem to have more positive outcomes in those children that are adopted in later years of childhood. Exactly, Leanne. And that sort of, if you will, defies this bias that people have against homosexual couples. I promise you that if I'd been raised by homosexual parents, I would still know what I am. I don't think seeing my father and father kiss would have done anything for the things that I feel inside myself. But you know, that's sort of the systematic bias that is built into our society. One day maybe it'll be gone, but unfortunately, not so much. Right? Now, the epigenetic view. The weird thing is, you may have genes, but genes have to express themselves. Not all genes are expressed, and some genes are expressed at different times based upon environmental situations. So the deal is, development is the result of an ongoing bidirectional interchange between heredity and environment. Your genes create your environment, but then your environment can cause genes to express themselves. So, epigenetic mechanisms involve a molecular modification of DNA strand as a result of environmental inputs. And so just because you have the gene for something, you may not that gene may not express itself and create the proteins that cause something to happen. So aside from the heredity environment correlations, it actually may be such that your environment causes a gene to become active. Exactly. They wouldn't. That's a good point, Crystal. I wouldn't have known how to make a different choice anyhow. It was something that I felt inside me. That's a really good point. All right. That is the end of today's lecture. Whew. Thank God I got done with biology. I hope I didn't make myself a fool out of myself in my genetics lecture this week. I'm just hoping that I know a little bit more than you do. And I hope I didn't say too many things that were incorrect or foolish. I know, right? Only 40 minutes today. Usually I bore you for 50 to 55 minutes. I hope you had a good time. If you said it was short, hopefully that means because you really enjoyed it and found it interesting, Etta. So I'm just going to go with that, right? Well, good. I'm glad you know more. All right, remember, next week we are going back to our Monday, Wednesday lectures, which we will be doing for the rest of the semester unless something unforeseen happens to me. Thank you folks all for coming out Wednesday night to the optional webinar. It was absolutely fabulous and a lot of fun. Don't forget to do your discussion board tonight so you can get credit or extra credit for this week's collaboration grade. And if you have any questions, do not hesitate to send me a remind, text, or an email. And after I get off this class, I'm going to show I'm going to share Kenzie's very heartwarming video of the child with the chromosome disorder. Okay? Thanks, folks. Y'all have a great afternoon and a great weekend, and I will see you next week.